Hello, this is Dr. Amulapriya, Associate Professor Triply from Rohini College of Engineering and Technology. We are discussing about the course Protection and Switchgear, and in this lecture we'll be dealing with the numerical relays. What are the fundamental requirements of a numerical relay? Since it is a numerical relay, it deals with the digital data. So obviously the speed, sensitivity, reliability, selectivity, simplicity and economy are basic requirements of any numerical relay. While considering its block diagram, we can see the current transformer and the voltage transformers are providing the respective parameters to the signal conditioners in order to remove the noises, and after that we can provide it to a sample and hold circuit in order to provide the exact part of signal which is needed, and those two are then provided to an analog multiplexer, and this analog multiplexer output is then fed to the ADC, analog to digital converter. Finally this digital output is then sensed by the or else provided to the microprocessor system or a microcomputer or a microcontroller system that will be controlling, it will be checking it with the standard one. If you compare the ADC output with the standard signal, and if suppose the signal is found to be under fault condition, obviously the tripping signal will be sent to the trip circuit through the microcontroller. In utility and industrial electric power transmission and distribution systems, a digital protective relay is purely a computer-based system with a software-based protection algorithms for earth fault detection. They are functional replacements of electromechanical protective relays, as well as for metering, communication and self-test functions it can be used. Numerical relay may consist of many functions in one relay, so thus it replaces many, the count of many traditional relays. One relay can be used in many ways. This is what is the thing. So no mechanical moving parts is there, and hence the wear and tear, those problems may not occur, and it is compact in size, and so it is the aesthetic look is also better. And then many complicated functions while we are using the gate circuits may occur. In such a cases, numerical relay may provide a solution, and this gives an entire detail of the fault record including the graph details. So we can easily observe and infer about what type of fault has been occurred, when it has occurred, to what level it has occurred, etc. Some relays have different setting groups. The advantage of settings groups is that the user can change the entire settings of the relay by simply changing the group setting. Frequent configuration is not needed. The main advantage is the communication between the relays and other equipment in the network is possible for doing automation of the system. So we can see this is a display of a numerical relay in practice. Here we can see how it's been connected, etc., and how the display of the unit is there. Low voltage, low current signals are brought into a low pass filter that removes the frequency, and after that it's sampled. The AC signal is then converted to digital signal. Actually here the Fourier transform principle is being applied, and more advanced analysis can also be used to determine the phase angles, power, reactive power, impedance, waveform distortion and other complex quantities. These are all about the input processing. While we are considering the logic processing, the relay analyzes the resultant ADC output to determine if action is required under its protection algorithm. Then that's the simple thing. If this signal is first compared to the standard signal, whether there is any fault occurrence or not, it is being detected. If a fault condition is detected, output contacts will operate to trip the associated circuit breaker. This is the front side. It consists of LED configuration menu, LCD display, numerical keypad, LED reset button, menu button, control button, breaker on or off buttons, escape button, and then the run LED and error LED. When considering the different types of numerical relays based upon the logic, they can be classified into overcurrent, earth fault, or directional overcurrent relay, differential relay, under voltage, over voltage, distance relays. Upon the characteristics, we can have it as instantaneous relay, definite time relay, inverse time relays, voltage restrained overcurrent relay, current relays, voltage relays, frequency relays, power relays, etc. So these are the different types of the numerical relays. Normally based upon the application, it can be a primary relay or a backup relay. If the protection system fails, the whole network might get collapsed. So they use the backup relay. Doing this will be helping the protection system even if the primary relay is going faulty for a certain time period, not full time. Thank you.